Yeah, welcome back to the last aspect of our differentiation, which is implicit differentiation. If you are just coming on our channel today and you're a new member, you have to go through the lessons we have taught so far so that you can have a deep understanding of where we are coming from. I am Latif Ismaila Akombi, your mathematics and chemistry tutor. If you are a new member on this channel, kindly subscribe to my channel and click the notification bell for my subsequent content. So let's dive in. Now, example 1, differentiate each of the following implicitly. So far, we have been looking at functions y is equal to f of x, where we are differentiating in terms of x, differentiating y in terms of x explicitly. But now, this is implicit differentiation, in which the two letters we are talking about, they are in the same phase. Implicitly, they are inside. Look at this. X squared plus y squared is equals to 4. It is not y is equals to x squared. But now, x squared plus y squared equals to 4. They are inside. Now, how do we now go about this? Now, it's just a simple logic. Anytime you are differentiating a function, you have to put the y, the x, or the x, the x. Let's say, for instance, the first one, we have x squared plus y squared is equals to 4. When you differentiate this one, we have 2x. It means you are differentiating x with respect to x. So which means the x plus, when you differentiate this one, we have 2y. So differentiating y with respect to x, the y, the x. Y, the differentiation of a constant is 0. And look at this. The x, the x will cancel each other. So this is the reason why when we are differentiating x, we don't need to put the x in order to avoid confusion. So here, this cancels this. We have 2x plus 2y, dy, dx equals to 0. Since this is what we need, and from our previous lessons, I always say the unknown will be at the left hand side, the known should move to the right hand side. This has to move to the right hand side. So we have 2y dy dx is equal to, when plus 2x is crossing, changes to minus 2x. Fine. We need our dy dx. We have to find a way of getting rid of 2y. So we divide both sides by 2y. So 2y dy dx is equals to minus 2x, then divided by 2y, divided by 2y. 2y cancel 2y, dy dx is equals to 2 goes into minus x over y. So that is our dy dx. We are able to differentiate this implicitly. Now, let's look at the second one. B, x squared y plus y squared x plus 4x is equals to 1. When we differentiate this x squared, we have 2x. Then you put your y. As I explained here, you don't need to put the x, the x again because they will still cancel each other. So as I differentiate x squared, it becomes 2x. Don't forget y is still there. You put the y to join it. Plus, if I want to differentiate y, I will not touch x squared. It will be x squared. If I differentiate y, it will give me 1. That is times 1. Then I will now put the y, the x. Don't get confused, please. I am differentiating this one, this value x squared y. X squared y. If I differentiate x squared, y will stand alone. That is, differentiation of this one gives 2x, then y standing alone. C, I will differentiate y, x squared will stand alone, plus x squared, because I'm not differentiating. If I differentiate y, it becomes times 1. Because I'm differentiating y, I will now put dy dx. That is what I'm doing here. Now, I've done this. Let me move on to this one. Plus, if I differentiate y squared, x will stand alone. 2y, but I'm going to put the y, the x. My s is still there. I have done this one. Plus, if I differentiate x, y square will stand alone. Y square. Differentiation of s is 1. Don't forget, this point in further mathematics, it means multiplication. So if I'm using points, I'm referring to multiplication. I've done this one as well. Plus, if I differentiate 4s gives 4 is equals to differentiation of a constant equals to 0. Fine. Then I have 2xy plus s squared times 1, s squared dy dx plus 2y dy dx plus dy okay, this 2y dy dx x. So 2y times x, I'm going to have 2xy dy dx plus y squared times 1 y squared plus 4 equals to 0. Fine. I have to collect like term. My dy, all dy dx together, s squared dy dx plus 2xy dy dx. Then let me take this one to the other side, is equals to, this one is going there, minus 2xy. Fine. This one is going out, minus y squared. This one is going out, minus 4. Collect here, dy dx is common. Dy dx is common factor, open bracket, s squared plus 2xy, close bracket, is equals to minus 2xy minus y squared minus 4. Now, to get my dy dx, I have to divide both sides by this value. So, dy dx in brackets s squared plus 2xy divided by s squared plus 2xy is equals to minus 2xy minus y squared minus 4 divided by s squared plus 2xy. So this cancel this. So dy dx is equals to minus 2xy minus y squared minus 4 divided by s squared plus 2xy. So this is the dy dx when differentiating implicitly. Now I want to differentiate this. Okay, let me differentiate y. 2 times 4, we have 8y dy dx. My s is still there. Plus, differentiating x, this remains the constant, 4y squared. When we differentiate our s, that is 1, minus, we have left this one. Now, we want to differentiate this. 2 times 5, we have 10x. Then you put your y cube. Plus, want to differentiate this one. This remains the same, which is, let's say, open bracket, minus 5x squared multiplied by, if you differentiate this one, we have 3y squared dy dx. We have left this one. Then to this one, plus differentiating this one, we have 4 dy dx equals to 0. Hy times x, 8xy dy dx plus 4 times 1, 4y squared minus 10x y cube plus and minus, we have minus 5 times 3, 15 s squared y squared dy dx, then plus 4 dy dx equals to 0. And let's take all dy dx together. We have 8xy dy dx, another one, this one, minus 15 s squared y squared dy dx, then this one plus 4 dy dx, this one plus 4y squared, then this minus 10xy cube. Okay, this, let's take, so this equals to 0, don't forget, equal to 0. Now, let me take this moves out, this moves out. So from here, the common factor here we have dy dx, open bracket, 8xy minus 15x squared y squared plus 4. Then all this one moves out. I'm going to have minus 4y squared. This one moves out plus 10xy cubed. Now I have to divide both sides by this value. So my dy dx will equals to, if I divide it, so I'm going to have minus 4y squared plus 10xy cubed divided by 8xy minus 15x squared y squared plus 4. So that's the differentiation of our implicit function. The last part, want to differentiate this. The first part is to expand this. X plus y and x plus y equals to 5. X times x, x squared. X times y plus xy. Y times x plus xy. Y times y plus y squared equals to 5. X squared, when you sum up this one, we have plus 2xy plus y squared equals to 5. Let us now differentiate this implicitly now. Differentiation of this one, we have 2x plus, when you differentiate this x, y will remain constant. We're going to have 2y. That's it. Differentiation of s, it has 1 at the power. 1 times 2, we have 2. So 1 minus 1, we have 0. So anything plus 0 is 1. 1 times 2, we have 2. Then y is still there. Okay? Plus, I differentiated x. I want to differentiate y. If I differentiate y, 2s remain constant. And y becomes 1. Isn't it? But it's going to become dy dx anytime I'm differentiating for y. I've done this. Move on to this. Plus, differentiate this, we have 2y. Then dy dx. When I differentiate a constant, we have 0. So here, let's collect like term, and this will move to the other side. 2x times 1, 2x dy dx plus 2y dy dx is equal to, let this one moves, minus 2x minus 2y. Okay, dy dx, open bracket, 2x plus 2y, close bracket, is equal to minus 2x minus 2y minus 2x minus 2y. So I'm looking for my dy dx. So my dy dx will be equals to, we divide this by both sides, minus 2x minus 2y divided by 2x plus 2y. Now something is common here, minus 2, open bracket, x plus y. No, minus sign is plus, we are going to have minus here, divided by, what is common here? 2 bracket x plus y. This cancel this, 2 here, 1, 2 here, 1, we have minus 1. So we have come to the end of the rules guiding differentiation. In our next class, we are going to start with trigonometric function, differentiation of trigonometric function, and also differentiation of angles. Just before we leave the class, if you are a new member on this channel and find this class interesting, kindly click the subscribe button, and do not forget to click the notification bell and choose personalize, so that anytime I release a class, a lesson, you will be able to see it as a first time information. Thank you very much. I remain Latif Ismail Akambi, your mathematics and chemistry tutor. See we meet.